How to read and accumulate sensor values at high frequency, without constantly writing to disk, raspberrypi 2B+, MCP3304, Python. I am attempting to use a Raspberry Pi 2 Model B Plus to read analog data on ear intensity from a photodiode via an MCP3304, 5V VDD, at a rate of 10 kHz 3 times in a row, 0.1 milliseconds between readings, or a rate of 10 kSps, once every second based on an external stimulus, average those values, then write them to a text file along with the current date time. The photodiode is simply reading out data to an amplifier, which then feeds into the MCP3304, which, via SPI, feeds data into the raspberry. In essence, raspberry receives a digital input, triggering 3 consecutive samples from the photodiode via an MCP3304 and inline signal amplifier. Those 3 samples are stored in memory, averaged, then written to disk along with a date timestamp to an existing CSV text file. This is all on Python 2.7. As it stands, I'm getting a sampling of is lower than 1 kHz with the below code, sensored. I am very new to Python, and playing with sensors and RPIs, for that matter, and think the way I've set up my class to take 3 separate, consecutive AG samples and possibly my setup for writing to disk may be slowing me down. However, I can't quite seem to find a better way. Edit 1. I've done a good bit of research on max sampling rates via Python from the raspberrypi, and it appears to be well above the AGS restriction at 1 MHz or 1000 kSps, for example 1,2. Edit 2. Perhaps the AGS max sample rate of 100 kSps actually refers to how many bits can be read rather than how many full 12-bit samples can be taken per second? Yup. This was it. The MCP3304 can do 100 kSps, but the Python read rate is closer to 30 kSps, which, when split between the 24 bits read by the MCP3304 per iteration, is closer to 1 kSps. My 2 questions. 1. Are there any better ways of getting closer to the full 100 kSps advertised in the MCP3304 spec sheet? This link suggests calling raspberrypi every time I want to take a single sample may cause some considerable latency. And 2. Is it possible, with a beginner/moderate level of Python skill for me to do all of this sampling and per second averaging in the memory, and only write to disk, say, once every minute? Edit. Could you please point me in the direction of some related link/resources? Thanks. Note 1. The code is threaded because there are some other functions running simultaneously. Note 2. I am also simultaneously reading a differential channel on the ADC, hence the differential equals true in the MCP3304 command. Edit. I ended up getting some great results with Python, as demonstrated in this test code I wrote to quantify how fast I could read my ADC. I also ended up writing my own function to read from the MCP3304, which I'll link to once it's all clean, that I was able to further optimize in Python. One point about your question. 3 samples in a second is a rate of 3 Hz, not 100 kHz. Sounds to me like what you want is 3 samples 10s apart. One, 10s sample period on MCP 3304 using Pi running Linux. Quite possibly not. Do some searching. See for example, this URL, where one answer says they achieved 33 kSPS, using C code and avoiding the SPI driver. Also, I suspect you will find Linux process switching and other threads getting in the way and affecting the sample rate, particularly if they are also reading the ADC. This may be more likely if you have a dedicated non-Linux processor to read the ADC, programmed in C or assembly language, feeding the 3 samples to the Pi. Easier if you use a parallel ADC, i.e. not using SPI like serial comms. See also, this URL, and this URL. 2. While the sampling at tennis period using the MCP 3304 is difficult to impossible on Pi, the averaging and writing is definitely possible. I have a solution for your problem, though. If literally all you're going to do with the 3 samples is to average them, why not add an old-fashioned low-pass analog filter before the input pin and then just take 1 sample? Hey presto, no need for hardish real-time ADCing, no need to worry about other processes or kernel interrupts.
We have recently benchmarked PicPio and raspberrypi with regards to the accuracy of reading inputs at different frequencies. The test was performed on a Raspberry Pi 3B. I would suggest to use the PicPio for better results. On our test, the max read frequency on that library with a read accuracy above 99% was 20 kHz, compared to 5 kHz on the raspberrypi library. You can find the exact test setup and the complete results on this post, this URL.